Before we do preventive maintenance on the guest room air conditioning units, make sure that the thermostat is in off position, especially when you clean the air filters and replace the fan motor. Always make sure that the thermostat is off. Cal from LG will explain why do we have to do that.
So the reason we want to turn the system into the off mode before doing any preventative maintenance is it allows the expansion valve to reach a full closed position, blocking any refrigerant flow from the rest of the system that's still operating from passing through that coil without our fan motor on and without the ability to flash that to a gas, right? So we want to prevent liquid from flowing through our evaporator and back out to our condensing unit and causing just liquid coming back to the compressor.
Thank you, Cal.
Thank you.
Do you have any more questions, Mark?
That's the main one I was really concerned about. Just thought of a question that it's happened to a few guests on and off through the years too. Let's say a guest is moving around the room and you have your motion sensor in the thermostat. Okay,
Right.
that kind of turns everything on, turns the lights on. Let's say and it's happened, they've been in the shower, in the bathroom for extensive time, there wasn't any movement in the room, and all of a sudden their lights go out and they're in the dark.
Right.
They're calling the front desk, my lights just died. Well then, we knock on the door, they go and they turn the doorknob, and as soon as they open up the door, all the lights come back on again. Is there a way of changing the timing on that sensor in the thermostat so it stays on longer without the motion in front of it?
That'd be a question for Honeywell.
Okay.
Yeah, that's
Unfortunately, I don't know the answer to that. I have heard of that situation in other hotels in the past. Their solution was either adding more motion sensors throughout the rooms, just so anywhere they're moving around would get caught. And then I've had them remove it altogether, just because if someone's laying in bed not moving, it'll go out after a certain amount of time.
Wow, that sounds pretty extensive.
It is. It has been a problem I've heard of quite a few times. Yeah.
Oh, okay.
So.
One more question regarding the LG AC unit. If we hear that refrigerant flow noise, what should be the first step as engineer or first responders? What should we do now?
So when you're hearing a refrigerant flow noise, the first thing I do is start making notes of which units are doing it, so
Okay.
we can look at a bigger picture. Is it a specific unit on a whole system? Is it the whole system that's making noise? If these are heat recovery systems, they'll have heat recovery boxes. So it's basically a branch box that serves multiple fan coils, right? So from our outdoor units, we come down to a branch box. We separate into probably 4 based on the age of the job. So it'll feed 4 off of that one branch box. So it could be specific to 4 units, a group of 4. It could be specific to an entire system, or it could be specific to a single fan coil, right? So the more information that you can get about how many systems are making noise, and if they're all tied together, or if it's just
If it is, let's consider it as a scenario. If it is the 4 rooms that's connected to one branch box, and that 4 units are noisier than the other ACs in the same floor, do you think that branch box might be failing? Is there an EEV valve on that branch box?
Yeah, so each branch box is going to have several solenoids and several EVs for each connected branch, right? So if we have a 4-port branch box, we're gonna have a solenoid for 2 solenoids per fan coil that's connected, and then we're gonna have multiple EVs that are within the branch box as well. So it could be any one of those that are causing the issues. It could be any one of the EVs in the indoor units that are causing the issues, or if it was a full system, it could be any EV or a lack of refrigerant. So it's definitely a refrigeration issue, and it takes a lot
100%.
more.
Considering lack of refrigerant, low refrigerant as number 1 possible causes, will it be okay if we charge 10 pounds of refrigerant to the loop, to the floor, one floor? Let's take 8th floor as an example. If we charge additional 4 pounds, start with the minimum. If we start 4 pounds to the 8th floor loop, is the system designed to take that pressure?
So here's what I'd say about anytime you know there's a leak,
Yeah.
right? So if we know there's a leak, we automatically know our system's a 410A system, so that's
Yeah.
the refrigerant we're using, right? This is a mixed blend refrigerant. So anytime there's a leak, we don't know what's left of the blend that's in the equipment, right? So anytime there's a leak, you need to pull the full charge of the system, right? Then as you're pulling the full charge, weigh it out, you know exactly how much you got out, right?
Yeah.
Just so you know an idea of how much actually leaked. And then there's a LATS program that's was used to build this project, right? So each system has a LATS built for it, and this LATS determines pipe sizes, pipe lengths, and is the only way to accurately charge the LG system, right? It's based off that LATS program.
And is there anything on the condenser side which tells us that the charge is, like the pressure or the amount of refrigerant is accurate? Is there any way, any sensor which tells us this is low on refrigerant or error code on the unit?
So you will get some error codes if you're drastically undercharged, right?
Okay. On individual units?
No.
On the
it's
main
gonna be
condenser
on the
unit.
main condenser
Is that
unit, right?
CS150 or different code?
Oh, there's a variety of error codes that can happen from low
Where can we
refrigerant
find
charge.
that error code?
So there's the service manual specific to the outdoor unit. It'll have a full list of all the error codes for all the components in the outdoor unit, all the components in the indoor unit.
Okay.
But there's a tool, it's called an LGMB drive that you hook up into the outdoor unit, and it pulls up all the pressures, all the temperatures, does a bunch of calculations for you, and it's very in-depth, right? You gotta have a deep understanding of the refrigeration cycle and the specific equipment. So that's the only way you can diagnose if a system is low on charge, is to be able to review that data.
Yeah, thank you so much. One more question regarding each individual air conditioning unit. Temporarily basis, like can we install insulation, like soundproof insulation for the control box or the valve or inside this coil, right? Is that something that we can try on these 10 rooms with the air conditioning noise?
So what style fan coils do you have? Are they wall mount units?
Wall mount split unit.
Wall mount split units. So you want to insulate the inside of the fan coil
Yeah,
for soundproofing?
soundproofing.
I would say as long as it's not blocking any airflow, and you're not using anything. Oh, perfect. Yeah, the LATS program. Yeah. So this is the LATS tree, right? So, like I said, this is the only way to accurately charge it. So you have your additional refrigerant charge, and then you'll have the nameplate data on the system itself. So if you look at the nameplate of the condensing unit, it should have the factory charge that was provided, and then you would need to add this additional charge on top of that, right?
Sure.
But as far as any additional insulation for soundproofing, the enclosures are pretty tight as it is, so you're probably not going to get too much. But yeah, anywhere where it's not going to touch the fan blade or block any airflow, yeah, absolutely no
I
problem.
will bring an EEV. That's what exactly we are trying to laminate.
Yeah, that guy right there.
So the noise is actually generated mostly around the valve.
Right.
What we are looking forward to is like laminating around that valve.
Oh yeah, wrapping this valve
Wrapping this valve
insulation. So it would say these are passively cooled.
It is good, yeah. 12 volt, right?
Right, yeah, so they do get somewhat hot, but as the system's running, refrigerant's flowing through, and that should, sink away most of the heat. So I wouldn't be too concerned about wrapping this down.
Yeah,
You
so
should have no problem.
can you discuss with your manufacturer, LG, and bring up with the custom wrapping, like decibel, like, some soundproof?
Yeah, we can certainly bring that up and see if they
We would like to
looked at
test
it in
in
the past.
these 10 rooms and see whether that makes any difference.
Yeah, we can do that for sure.
Sounds good.
All right.
Thank you. That's all question from me. Thank you, Kyle.
Excellent.
Any question,
Any
Mark?
other questions?
Well, one I was thinking of is, why do some units create so much condensation on the ceilings than others, where it does damage to our ceilings? And then the paint curls, and we have to scrape it and patch it and repaint just immediately above the unit itself.
It's like the return here. Condensation.
Yeah, like
It's
water
too
beads
cold?
off the ceiling. During the summertime when we crank it down, not in the winter time, but the summertime, we're running it cold.
So, Are you only seeing that on like the very, very hot days that we had last summer?
It's over time, I believe. Like
Yeah.
after a month of AC running full time, the AC unit is installed, let's say 2 feet below the ceiling, so it's really close to the ceiling.
Right.
So the return air circulating through the AC, actually high humid probably, it hitting the ceiling. We can go to one of the rooms and I
Sure,
think
like
that
805, you're talking about maybe a space about like
1 feet,
this.
6 inch.
Enough just to get a
6
putty
inches.
knife in there to patch it then, because it just really does damage that ceiling. And that's just a handful of units, but why is it some units and it kind of other units, you know, it just kind of,
So that's another one where you'd have to look into, you know, of what it's connected to. So for example, like this unit over here is at the very far end of the piping, right? So we're gonna have, ideally it would be perfectly symmetrical throughout the whole system, right? But we're gonna have, you know, maybe a small decrease in performance all the way down here at the end. You know, especially if everything's not completely accurate on lengths.
okay.
So maybe it's the first heat recovery box that's connected, and that's why that system's getting colder. We're getting, you know, better refrigerant flow in that situation.
Okay.
But with that said, you know, that should be something that's fixable.
Okay.
So
Okay.
That's
We've
good
only
too.
seen a couple units that maybe had some ice on it. Just a couple. Okay.
Thank you, Carl. Any questions, Carl?
That's
Okay.
about it for now.
Thank you. Any question, John?
No.
Okay. Thank you so much.